Today, I'm going to teach you how to leverage large language model to tune your some machine learning model or even beyond working on your workflow. So my name is Huijo Kim. I work as a senior data scientist at Voice. So Voice is Hamburg-based, fast-pacing, growing startup, and we do offer AI-powered procurement software to maximize availability, minimize cash flow investment, and cut 90% of manual planning time for e-commerce brands. So after this talk, I will promise you that you are going to learn a design pattern using MCP as a tool set and your domain knowledge in your industries. So I'm going to demonstrate on hyperparameter optimization as a one sample cases, but it will be beyond of this only hyperparameter optimization or tuning. So you are going to live with a blueprint for putting large language model into your decision loops and also with some guardrails. So if you do machine learning, that's great. Please take as a sample project that, hey, I can do hyperparameter optimization with large language model. Even though you don't do it, so you can reuse it. This will be a reusable pattern for agent-driven optimization. So gradient boosted tree is one of the very famous machine learning framework. It's really winning across over competition or even industries. I used to talk to like other machine learning or data scientists, hey, what do you use for your data to make some prediction or to forecast? To be honest, it's not always really deep learning, which people are really like crazy about. But mostly I'm hearing that, hey, I use LightGBM or XGBoost. Or when you go to Kaggle competition, more than 60, 70% of winners are utilizing this LightGBM or gradient boosted tree. So this is super powerful, but there's some limitation of using this machine learning model framework because there are 14 to 19 tunable hyperparameters that you have to really select and then really tune, hey, this value should be 0, 0.1, 0.001. So this is something we have to iteratively search for the best parameter. So one famous thing is learning rates or other thing, regression parameters for noisy data, or is this model really have to go to deep or really the wide, or when we are doing some self-sampling, some strategies. So this right parameter is not something you can get from the textbook. That means it really depends on your industry and data set. So often senior to junior telling, hey, you start with this 5 hyperparameter, and you run some tuning overnight, then you will get decent results. So this is what has been happening. And Optuna is one of the very famous framework in this hyperparameter optimization because we don't want to do every greedy search over whole dimension because we are going to fall into curse of dimensionality. That's why Optuna is doing a smart job already. What it does is doing some Bayesian optimization based on previous hour training or fit, and it tried to do more promising region. We do more fit and try. But still, it needs some exploration before doing it needs some like exploitation, so which means we have to run like a few decades or hundreds of like run before do some exploitation. So for 5 parameters, in practice, about 200 iteration is a good starting point. So if your model requires just 1 minute of fit or train time, then it takes 200 minutes, so 3 hours, acceptable. But if it takes 100 minutes or longer, then it's 5 parameters is already like hard. And when it comes to, I want to exploit everything, so I want to find the best parameter for my like forecasting or prediction model, then you can't really make it within the time. So our goal is we are going to find some middle ground utilizing, hey, large language model is so powerful to do some reasoning, and why don't we use it? So before really going to agent thing, so I want to get us aligned with some terminology. I'm sure like all of us are hearing a lot about Claude, ChatGPT, Codex, and Gemini. And people are like sending some LinkedIn posts, hey, I have built this MCP, and this is a skill, you can integrate this. And everybody has some slight different like definition of their own. So let us like align with Anthropic's definition, because to be honest, they have embedded MCP, and they are pushing forward very hard for the skills. So based on their definition, which I also very like, MCP is about connectivity. So one analogy is a kitchen. So it provides tools, ingredients, equipment. So in our case, we can get some real-time data access, such as like database, and there's a tool invocation, what kind of tools are available, and then explain what it does. So it's all about what Claude or Codex Gemini can do, and skills is about domain knowledge. So it's a recipe, focus keyword is step-by-step interaction. So there's step 1, you do this, step 2, you do this, and based on step 2's result, agent is supposed to do action A or B or C. So this is something we are going to enforce, and our whole goal is user accomplish complex tasks without giving too much of like manual intervention. So in our case, I'm talking about hyperparameter optimization. Then Cloud Code will utilize MCP tools. So MCP will, which is a kitchen, will give 8 tools. So large language model or agent is not going to do some random stuff. So we will predefine, hey, you are supposed to do these 8 tools. So in our case, get campaign status, get round summary, get campaign history. So here campaign means, hey, let's run one campaign. And it's going to run like 200 or 2,000 iteration. And then each round we will define. I will get more details. And then in the end, agent is going to act on, hey, what action I want to propose, and then just run the next. And at the same time, skill is about tuning guide. So not only you are just owning as a team or as a company, you can document it. If this is what is happening around this parameter, then we need to do this action A, action B. So let's get to more details. So this is one iterated like slide. One say existing one-go hyperparameter optimization. We submit, hey, this is a 5 hyperparameter that I want to optimize, and then just run over 200 cycle, maybe over one night or a week. But what we can really leverage is, let's not just do 200 trials, it's just one goal. We can split into multiple, and in the middle of that, LLM with the power of MCP and skills, and make a decision, hey, should we keep going on this, or maybe dump this hyperparameter, or we like switch it. So this is something we can really give a guidance in between. So we don't have to wake up in the middle of the night and then check, revise. Agent is supposed to do it. So let's do one demo call. I think that's more, I hope it works out. Okay. Okay. I'm using Claude for the sample case. So this will be the thing that I will ask. I will just make it bigger. Hey, let's do some tuning for certain data set. Of course, you can define that I have data set of e-commerce data. I have data set of farming. I have data set of something. Then, based on skills, we are supposed to define what you need to do. It looks like fancy initially, but it's nothing but we just write it down as a skill file. Hey, step 1, this is something you have to clarify with user. And let me just follow what needs to be done. I want to use LightGBM. I will use this. We'll just keep it very short one. What is shortest? I think almost same. So you can define some different modes. Hey, is it the right one? Just agent is doing whatever we have defined. You have to really get the proper input to the run this Optuna or other hyperparameter tuning framework. And Unfortunately, Postgres is not running, so I actually didn't run Docker yet, but it is going to run. Yeah, during this is it's running. Let me just continue on presentation. I will get back to you. So this is running on the left side. Okay, I think it's better I make it big. So this is the summary because it's going to take a couple of minutes. Or maybe we can revisit later. So each round, rather than we go full round at once, we will split into multiple rounds, and then LLM can just sit again and then use MCP as your kitchen tools. Check from the previous run, is it good or bad? We define coming from, let's say, LightGBM or XGBoost official documentation, and then what is each parameter is supposed to do. And then we also write some domain knowledge about industry, and it makes the decision over the time. And this is one like bigger sample I have just already prepared last night. So I made like 20 sample cases. So each 20 of like rounds, it makes decision, okay, keep going, keep going. I think we have to really reduce these two parameters and add these two. This will be it's going to make this decision in the middle of the work. It does nothing, but it requires skill based on your guidance. So this is how we can not only 20 go to 200, it can, because what I have some impression about using agentic workflow is I just want to have really the best moment. Okay, let me just skip it. Achieve best model performance, but I don't want to really spend my time, but let some electricity burn so we can achieve the best performance. So this is the way or framework that we can achieve this goal. So not only one sample case, I also included some more public data set. Want to really see, hey, it can produce some more meaningful, better performance. So then these are 4 public data set coming from scikit-learn. And I just compare with just using 10 parameter or all parameters in our agent tune framework. And then it got always not the worst. But here the catch point is, okay, this is going to change everything about hyperparameter optimization. I don't think this is the right conclusion, that we already have our very well performing framework. On top of that, we will just iterate with the loop. Agent is going to make a decision in the middle of it. I want to, yeah, so during this talk, this is the one that we get some summary during the round, and then after this round, agent is making next propose, and then run it on and on and on. So, okay. So this is the pattern. So beyond hyperparameter optimization, first, agent is very powerful at observe some structured signals, because it can read like very hugely manufactured JSON data and then really keep tracking of it. Second, agent can diagnose via domain knowledge, but it has only like limited knowledge coming from the public or pre-trained data set. So we really need to define as a skill. Skill is nothing but README file or markdown file that we are really specifying. This is condition A, B, C, D, and then based on that, you do it. And next, agent can propose an action, but this action should be guardrailed based on our thing. So it's not supposed to do some delete of our database, or it only is supposed to define our predefined tools through our MCP, which is our kitchen. And we can enforce these guardrails that only can do the predefined tools, and keep repeating until we reach the point that we are happy with our results. I really strongly believe that it works for any domain with some decision loops. If you have to make some computation or some experimentation, and then you have to revisit. and revisit on and on, then this framework will really shine. So it can be certain optimization or infrastructure scaling or A/B test management, it will really work out. So in short, large language model will decide and code enforce, and MCP is the interface that it will really connect each other. Thank you so much for listening my talk. And all the frameworks are in open source in the GitHub repo, so you can check out. So also very short advertisement. So our team is hiring for data scientists and data engineers. So just get back to me, then I love to talk to you. Thanks.
Thank you for the insightful session. There are a few questions. What are examples of domain knowledge you would provide to our agent, to your agent? Do you have to modify this for each data set or each customer?
I would say it's really dependent on data set level, not the customer set. Of course, if one customer has a very strong seasonality data set, then of course you can enforce it. Let me make some simpler examples. So in my former work, I used to have the count of red berries. So this count of red berries are detecting from certain camera, and then we detect it. But there could be some blur from foggy air, or leaf is blocking, or there's some ant is blocking the camera lens. Then this can mean it's a noise for the counting the number of fruits, counting the number of some leaves. So this kind of domain knowledge we can enforce that, hey, if you see some certain drop, you might ignore this, or you can do some like smoothing. So this is the domain knowledge that I can think of as an example.
Okay. Is the agent able to tune parameters beyond the ML model, for example, data pre-processing?
So I think it will even shine more when it comes to like deep learning. So when I was doing like computer vision training, it takes a day or a couple of days for one training, because for LightGBM, it takes mostly likely 1 minute or 10 minutes, hardly go like more than an hour for just one fit. But when it comes to deep learning or other framework, then one cycle becomes very, very long. So we really want to reduce the waiting time for the human is deciding. So I think LightGBM is one example, but there are potential to apply other machine learning or deep learning framework.
Okay. Instead of running an agent and a custom MCP, wouldn't it be easier to have a callback to a model from the training pipeline after a run to ask for the next parameters to test?
This is actually a very good question, and also some like counter argument, because I also just here define, which is following Anthropic's guideline, skills as a recipes. But there's another approach that in skill, you can write it down, hey, this is API or this is a callback. You can just immediately run this query, or you can make some like request. It will also work. And some people say, hey, this is more token of efficient and it's going to work. So I won't say this is a bad approach, but there's two different words how to achieve the same goal. But to me, this is a simple and clean approach.
Okay. Could you show an example of skills you use? For example, this problem, what exactly the skills look like? What knowledge and rules do they provide?
Yes, for sure. I love to show really the case. So one skill I already presented is when I start some campaign, the question list that's asked, I think it's better I make it bigger. Okay. And the other skills that so it's all about markdown file, and I don't write this skill. If you go to Cloud Codex, ask, there's a skill called create skill, then you are going to create skill using this skill. So please don't write down this thing. And Claude will ask you the very good question, hey, what should I solve and what should I do? And then based on that, it's going to create these skills. And there will be tons of very nice materials in YouTube. Go and check out. But if you come back to me after this talk, I'd love to give some more demos and examples.
Similar question. What exactly have you provided? Like, what information does these skills provide?
Again, please.
What information is provided in skills here?
In this demo case.
Yeah.
So in these demo cases, I have prepared or injected only public data set, which I can just download from the public because I can't really expose our client data set from our work. But what in your workflow, what you need to do is, one, you define how to fetch your data from either S3 or from your local machine. Don't write it yourself. Ask Claude, hey, I have this framework, and then I want to inject my data set, not the public one. And second, I am using LightGBM just.fit. Probably you are supposed to have some pre-processing, post-processing. Again, ask your Claude, hey, I need to do some pre-processing, post-processing. So this is the extra work you need to do.
How do you avoid going into an overfitting mode?
This is, I think, beyond of this topic. I think I have to really come back to just standard answer or some boring answer. Please check your validation and accuracy and also regression term. For we should never drop this parameters for regularization, and then we can also check out from the large gradient boosted tree, but others you can also check out the other the delta between validation and test results. Yeah.
Can you do the same thing programmatically instead of calling an agent?
Yes, because what it does in the end is just calling some CLI that I define agent tune, some my project, and agent is not doing anything fun. It just called, I'm doing agent tune init with some parameter just to the CLI. So we don't really need agent to do it, but I think it's much easier for us humans that just write a natural language. Hey, agent, do X, Y, Z. Maybe you can spend 72 hours until you get the maximum output. So this is something much better to use.
Okay. Do you think we could use a VLM and use training plots as inputs for the hyperparameter optimization loop?
VLM?
Yeah, that is what is written, right?
Yeah. I think I can't really answer, so yeah.
Okay, I can ask the next one. How is the performance of past trials passed as part of the agent context?
So the question was, how much context is consumed by this iteration?
It is like, how is the performance of the past trials passed as agent context? You could read it here for clarity if you want.
If I get the question right, this is something I can't memorize, but agent is supposed to logging every performance over each run, and it also looks at what was the previous performance validation, also test, and then just keep tracking it. So I think I just answered.
Okay. Do you start with a coarse grid of hyperparameter values in the first trials to quicker determine which parameter to dump from optimization?
So this is, I think, something you will start with your default value that you are putting the default as a skill again. I'm repeating the same term again and again, and then agent will start from this starting point.
Okay. I think these were the questions that were asked. Are there any other questions in the room? Yeah, just a moment. I can give you the mic.
Thank you so much. I suppose there was a sequential setup on Optuna, right? So it wasn't parallelized. If it's possible to extend the MCP framework, the kitchen, in order to use the parallelized hyperparameter optimization, say I would like to use a cluster as a backend, or maybe even to use multi-core setup.
So this is for sure. It won't work immediately because our tool is predefined to call just sequential Optuna. But of course, you may define the tool that run next round underscore multi. Yeah. So I don't think there is any limitation because in the end, what this tool will do is call again this Optuna, input some input arguments, which is multi is true, and put the rest of relevant input there. Yeah.
Okay, are there any other questions? Okay, just give me a moment. Yeah.
Hey, thanks for the great talk. I was just curious whether you have seen Andrew Karpathy's auto research that he published about 1 month ago that is doing like something similar. Could you maybe elaborate on what are the differences, or whether you have also like considered using that for the purpose of your work?
I think I am for sure get inspired from this auto research, but I really narrow the scope of only focusing on this this problem solving. So I believe this is fundamentally the same approach to handle complex and looping problem, but Andrew's approach was more generic and really any research paper I will really build it. For me, I just limit my scope to hyperparameter optimization. So my short answer is it's doing the same job, but just problem was slightly different. Yeah.
Okay, thank you so much for this session, and that's it for today. This was the final session in this room, and now you all are invited to go on Spectrum on the first floor for the lightning talks.